So I'm going to be giving a overview of our xEVA, that's Exploration Extravehicular Activity Overview. I'm part of the EVA Development System Engineering team. I lead the management of the system engineering team. And as you're going to see, we are well engaged with all of our providers and vendors that are going to be providing us hardware for EVA. Brian Alpert is also online with me. He is our cross stakeholder integration lead within our program EHP. I'll talk about EHP in a second as well. And just echoing what Jake and Stephanie were just mentioning on integration, we have been emphasizing integration with how do we bring science inputs down to our program and with our hardware providers as well. And Brian Albert helps us with that. Then go to the first slide and introduce what EHP is. EHP is our EVA and Human Service Mobility Program. So it's basically our human operated rovers. So any of the rovers that could fit a human being, though they will operate autonomously as well as our EVA hardware that includes the suits and a lot of our associated equipment like vehicle interface hardware, geology tools. We build quite a large group of EVA hardware overall. We also, within EHP, do have some technology integration and partnership going on as well with a lot of the future technology development. So where are we going to look in future Artemis missions? Is there technology we could currently develop today to help us with those missions down the road? So we cover a pretty wide breadth within our program, but today we're going to really focus on the EVA portion of that. Next slide. A quick note, I know all of you are really focused on lunar surface science, but we are supporting the International Space Station. So I do want to put a quick shout out for ISS out there. Some of you may also be supporting some of the science that we're doing in ISS. We are responsible not only for lunar surface EVAs, but also for the ISS EVAs. If you go to the next slide. So what we're doing, as we're supporting both Artemis and ISS, we are leveraging our industry capabilities and NASA's expertise to make sure that we could provide spacewalking and moonwalking services across the board. So as I mentioned, that includes the spacesuits, tools that could be maintenance tools, it could be geology tools, any tools that we might need to interface from an EVA standpoint, as well as any equipment that interfaces with, say, our spacesuit within a vehicle. We are building that on this team. And how we're doing that is we are enabling our commercial industry to be able to become our customer to supply us those resources. So we like to talk about how we are renting out the suits. We want to make sure that these spacesuits that are coming on board support our NASA mission, but also enable a lot of the commercial opportunities as well for spacesuits to be used for other things out in industry. Next slide. So what this means from a services point of view, we call this commercial services. The contractor owns the hardware and design. They are also responsible for the maintenance of that hardware. NASA is going to, at the end of the day, certify the suits to be used on ISS or on Artemis, but the contractors bring all the paperwork to provide how we are certifying that hardware. NASA is also responsible for the plan, train, fly when it comes to EVA operations. So there is a split between what our contractors are bringing on board, and we're going to talk about those in a second. That's Axiom and Collins Space as our two big contractors. And then NASA does have quite a bit of responsibility as well, especially when it comes to operations for plan, train, fly. So, Axiom Space and Collins Aerospace are the two providers. Many of you may have seen these in the news already. We've already announced Axiom and Collins at least for two task orders on our what we call the xEVAS contract. That's xEVA services contract. The contract was awarded back last summer. And since then, Axiom and Collins have been going quickly with their designs to deliver new spacesuits as well as accompanying interfaces and EVA tools as well. Right now, Collins Aerospace is focused on ISS and using their new suits as a replacement for their current EMUs that we use on ISS today, since they're getting quite old. And then Axiom Space has been awarded the Artemis 3 contract. So they are marching forward to providing that whole EVA system that we're going to be using on Starship for an Artemis 3 mission. Slide. Oh, sorry, this showed up pretty small. Hopefully you can read it. I I'm trying to bring things back to the science community. So when we talk about EVA and how we work with EVA from a science perspective, our EVA crew members are going to be doing a lot of the science. And so there's a couple different things to consider here. One are like geology tools, for example, on the lunar surface. And this is where we work really closely with folks like Jake out there on what are the requirements that we need for these geology tools? What do we have to be able to do while we're out EVA so that we develop the right tools and that the crew uses them correctly as well. So there's definitely a training aspect too. We're also going to be, I'm sure, deploying a lot of science payloads while we're out EVA. So there are interfaces that we're going to have to talk about when we have our EVA crew deploy a science payload. We have a couple of resources that are publicly available today that you could look at to get an idea of how to interact with our EVA suit, other EVA tools, and just the EVA crew member overall. One is actually a brand new paper that's coming out this summer for the International Conference of Environmental Systems. And that's the compatibility between the exploration EVA system and the exploration spacecraft. So how do we interact between the spacecraft and the EVA system? That includes payloads as well. It describes a lot of the history on our documentation and how we try to build our EVA system. How do we interface with the EVA system? And how can you design hardware to interact with that EVA system? The second one on this list is our concept of operations. So this is an EVA document. We are in the process of updating it. So it is over 2 years old now at this point, and we're going to modify it and hopefully publicly publish that as well here soon. But it still has really good resources in there, some really good pictures to show you some basics on EVA operations. And then we do have a NASA suit up page, and this is a really great resource if you want to dig a little deeper. We actually post our NASA design reference CAD models on there, so you could actually go to that site and take our CAD models. It's not the exact models as what we're going to see maybe Axiom or Collins bring to the table. It is based off of our NASA design reference, but it's still a really good resource to use if a CAD model is useful for what you're doing. And then we also have links to past EVA workshop presentations, different papers, there's podcast videos. It's a really good resource out there if you want to learn more about EVA. I think that brings me pretty much to the end of this presentation. I'm looking forward to your Q&A here in a little bit, and I do want to just end with a couple contacts on this page. So you've already heard from me. Brian Alpert is also online, as I introduced. He's going to help answer any questions that come our way here in a little bit as the cross-stakeholder integration lead in EHP. And then James Reynolds is our payload integration point of contact. He reports to Brian Alpert. So you could contact between the three of us. I'm sure we could point you in the right direction if you have any EVA questions.